3.1.1, we are asked to write down the first three terms of the series. So the first thing we're going to do is we're going to write our sum. So we are given our sum, which is 12 at the top and k being equals to 3. So it's 4 into 1 over 2 to the power of k minus 1. So to find our first three terms of the sequence, or the sum rather, so we're going to say k. When k starts at 3, we're going to substitute into this problem here. It's going to be 3. So let me write it properly. So it's going to be 3 minus 1, and the answer for this one, you need to get 1. And when k is equals to 4, it's going to be 4 into 1 over 4 to the power of 4 minus 1. And the answer to this one should be 1 over 2. K is equals to 5. 4 into 1 over 4 to the power of 5 minus 1. You should get 1 over 4. So punch this calculator to find your next three terms. So the next three terms of this problem here is 1 plus 1 over 2 plus 1 over 4. So 3.1.2 says that calculate the sum of the series. So the first thing you need to do is we need to identify the values that we found in 3.1.1, which are our first three terms of the series, and also define whether the series is arithmetic or geometric. Then we can use a formula of that series to find the sum. Remember that our sequence, or the first three terms, were 1, 1 over 2 and 1 over 4. So if you can see here, these terms are in fraction form. Okay, that doesn't really define on whether or not it's an arithmetic or geometric. So let's first find the ratio of these terms here and see whether or not they are geometric. So T2 over T1 is equals to T3 over T2. So T2 over T1, it's 1 over 2 divided by 1 equals to 1 over 4 divided by 1 over 2. So if you punch your calculator, you will find that R is equals to 1 over 2. So we're having a constant ratio of 1 over 2. So therefore, this is a geometric series. So meaning that we're going to use a geometric sum formula. So our A value is equals to 1, which is this one here. Our R is equals to 1 over 2. So we're going to find our sum. But before we do that, we need to identify the number of terms of this sequence here. Remember that the sum that we were given initially in the problem, it was sum of to the power 12 when k is equals to 3. So to find the number of terms, we say n is equals to top minus bottom plus 1. So the top, which is this one here, it's going to be 12 minus the bottom, which is 3, plus 1. So our n is supposed to be 10. So now we have our n value being equal to 10. So we are able to find the sum of the series. So now the formula for a geometric sum is Sn is equals to a into 1 minus r to the power n divided by 1 minus r. So our a value is 1 into 1 minus our r is 1 over 2 to the power of n, which our n is 10 terms, divided by 1 minus 1 over 2. So you're going to punch your calculator and the solution should be 1.998. Thank you so much for watching. If you have any questions, suggestions, or comments, please write them down in the comment section below. Otherwise, please subscribe to the channel and don't forget to click that bell button.